In part 1 of this video, we looked at how we might travel through time into the future, using a time machine that might resemble, well, no, not really. Our time machine probably wouldn't look anything at all like this phone booth, but it was the closest thing I could find. We discovered that traveling into the future is pretty straightforward thanks to Einstein's theory of relativity. Now we're going to look at a more difficult issue, the problem of traveling into the past. This kind of time travel presents all kinds of problems. Maybe you've already heard of the so-called grandfather paradox. We'll get to that in just a moment. But first of all, how would you actually do such a journey? The first thing worth noting is that there's nothing in the laws of physics that specifically prohibits time travel into the past. In fact, the second part of Einstein's theory, known as general relativity, suggests that it might actually be possible. In general relativity, matter warps both space and time. The larger the mass of a particular body, the greater the warping. And if the warping is extreme enough, one can imagine creating a loop in time, what physicists call a closed time-like curve. Follow the loop, and you end up back where you started from, not just in space, but in time as well. So how do you achieve such a high degree of warping? How would you warp time intensely enough to create a closed time-like curve? There's nothing in our solar system that even comes close to doing the trick. Instead, we would need some far more exotic astrophysical object, perhaps a black hole, or better yet, a wormhole. You can think of a wormhole as a black hole that has both an entrance and an exit, a kind of tunnel connecting one region of space-time with another. Now, this is quite speculative. We don't know whether wormholes actually exist, and even if they did, traveling through them might turn out to be impossible for a variety of reasons. But just knowing that such structures aren't prohibited by the laws of physics is already a stunning idea. If we ever discovered a wormhole that was not only stable but navigable, an astronaut could enter in one location and emerge not only in another place, but at another time, either in the past or in the future. A wormhole would function like a time machine. But if that kind of journey really is possible, then we have a problem. Because traveling into the past gets us into difficulties involving cause and effect. We would be confronted with the paradoxes associated with backward time travel. The best known puzzle is the famous grandfather paradox. Suppose you have a time machine at your disposal, either a wormhole with just the right properties, or some other exotic structure capable of bending space-time in just the right way. You use the machine to travel back to the time when your grandfather was a young man. Now, it would be rather evil to kill your grandfather just to test the laws of physics, so let's say that you kill him by accident. Perhaps you run over him in your car. So immediately we have a problem. Your grandfather won't meet your grandmother, and so their child, your own mother or father, won't be born. And therefore you won't be born. But if you're not born, how can you travel through time and kill your grandfather? It is, obviously, a paradox, so we need some way to resolve it. Over the years, both physicists and philosophers have given a lot of thought to the grandfather paradox, and they've come up with a number of possible remedies. One possibility is that the laws of nature somehow conspire to prevent you from killing your grandfather in the first place. Suppose you really are intent on killing your grandfather. You emerge from your trusty time machine and glance at a newspaper to confirm that it's the correct year. You track down the house where Grandpa lived, and soon enough you spot the old man, now, of course, a young man. For just a moment, let's suppose you are nasty enough to try to kill him just to test the laws of physics. And you're good with a pistol now because you've been practicing. So you raise the gun, you clearly have him within your sights, you can't miss. You squeeze the trigger and, well, presumably you do miss. The question is, why? This is where it gets interesting. No one is suggesting that any sort of supernatural intervention takes place. Instead, some physicists argue that some mundane event or series of mundane events prevents you from carrying out your task. Perhaps in spite of those hours of practice at the shooting range, you miss. Perhaps you have a change of heart at the last minute and decide not to proceed. Or maybe you slip on a banana peel on the way to your grandfather's house. One way or another, a series of such events must keep you from reaching your goal. But this does sound a bit strange, doesn't it? This line of reasoning seems to be at odds with the notion of free will. You ought to be able to do whatever you like, even while traveling through time. So if you're hell-bent on killing your grandfather, why would you accidentally keep missing, or accidentally keep slipping on banana peels? There's some subtle physics here, and some rather subtle philosophy as well. It's a bit more involved than what I can get into in this video, so I'll leave you to catch the details in Chapter 8 of In Search of Time. What these arguments boil down to is the idea that you can't change history. Roughly speaking, if you travel back in time, you can only do things that are consistent with the overall history of the universe. That is, if you travel into the past, you will only be able to do what you actually did. If Grandpa remembers a crazed stranger trying to kill him when he was a young man, then the time traveler simply is that stranger. If a time traveler witnesses some historical event, so be it, but that means the time traveler was there all along. In Part 1, I mentioned the fantasy of killing Hitler before the outbreak of World War II. From this perspective, you clearly wouldn't be able to do that. No one can kill Hitler in 1933, for example, for the simple reason that Hitler wasn't killed in 1933, and the war did happen. What's done is done. A third possibility involves what we might call parallel universes. In this scenario, you can travel into the past and kill your grandfather, or alter history in some other way, but your actions don't change history. That is, they won't change the history of the world as you knew it, but merely the history of another parallel world. You can see how this idea of parallel universes successfully gets around the various paradoxes. If you kill your grandfather, it merely means that there is a separate universe, a separate timeline, in which that event takes place. In that universe, Grandpa did meet a mysterious traveler from the future. If you happen to kill your grandfather, it means he won't have grandchildren in that universe. In the universe you came from, however, he lives to a ripe old age. History, that is, the history you were familiar with in your original universe, is safe. It certainly is a convenient theory, but it does seem to carry a lot of metaphysical baggage. At first glance, the idea of multiple universes sounds crazy. But actually, several different branches of modern physics all seem to at least hint at the possibility of multiple universes. One of them is quantum mechanics, another is the inflation model of the Big Bang. Even string theory seems to hint at multiple universes. So the idea might not be quite as crazy as it sounds. After weighing those alternatives, you might come to the conclusion that the simplest way out of the grandfather paradox is the first option that I mentioned, the idea that the laws of physics somehow prohibit backward time travel. The most famous endorsement of this position has come from physicist Stephen Hawking. He even gave that principle a name. He called it the chronology protection conjecture. Hawking admits that he doesn't know what the mechanism actually is that would prevent such happenings. But whatever it is, it makes the world safe for historians, as Hawking has put it. For now, of course, the idea of time travel into the past remains highly speculative. There are scientists who publish papers on the subject, and they're usually greeted with a fair dose of skepticism. But even if time travel were shown to be impossible, that too would be a tremendously important discovery. As Hawking has put it, even if it turns out that time travel is impossible, it's important that we understand why it's impossible.
In the end, the quest to understand time travel is about more than an infatuation with tales from science fiction. Thinking about the problem of time travel is forcing scientists to confront some of the most profound issues in modern physics. It forces us to think about nature's ultimate laws, to ask deep questions about cause and effect, to inquire about the fundamental nature of space and time. They're questions we have to confront as we journey in search of time.